How are you all? Are you okay? Very good. Tell me what's the date today? 20 March 23. Class monitor, please stand up and tell me what is the strength of the class? Okay. Total strength 40. How many students are present? 36. 4 students are absent. Okay. Yesterday in the previous class, we have studied about the zero order kinetics. Yes, you please stand up and tell me what is the zero order reaction. Okay, very good. Please sit down. Yes, you tell me what is the integrated rate equation for the zero order reaction. Okay, very good. Now I will repeat the zero order kinetics. Consider generalized reaction in which reactant R is converted to the product P. The zero order reaction is a reaction in which the rate of the reaction is independent of the concentration of the reactant molecule. R raised to power 0 means 1 equal to 1. It means rate is equal to K. That shows that rate is independent of the initial concentration of the reactant. And its integrated rate equation is R0 minus R is equal to Kt. And its half-life is T half equals to A0 by 2K. Now we will study about the today's topic, that is the first order kinetics. First order kinetics. Before studying the first order kinetics, we have to know that what is the first order reaction. So, consider a generalized reaction in which R reactant is converted to the product P. And first order reaction is the reaction in which rate equals to K into R raised to power 1. Means rate depends on concentration of the reactant. Rate is directly proportional to first power of concentration of the reactant molecules, where K is the rate constant. We also studied about the differentiated rate equation in which rate equals to minus dr by dt. That is, rate equals to decrease in concentration of the reactant molecule with time. Negative sign represents the decrease. By these two equations, equating these two equations, K r raised to power 1 will be equal to minus of dr by dt. Now, rearrange this equation. Dr by r will be equal to minus of K dt. Now, to find out the integrated rate equation, we will differentiate these sides. K is the integration constant, so it will come out of from the integration sign. And we know that dr by r, the integration of dr by r will be ln r and integration of dt will be t. Now, integration of dr by r is equal to ln r equals to minus k into t plus c. Here c is integration constant. We can easily find out the value of integration constant c by using the equation t is equal to 0. Initially, when the reaction is not started, the time t is equal to 0 and r will be equal to r0. That is, r0 is the initial concentration of the reactant molecules. At time t is equal to 0, r will be equal to r0. Now we will put these values in this equation. By putting these values, ln r0 will be equal to c. Now we find out the value of c, that is equal to ln r0. Put the value of c in this equation. equation in this way. ln r naught minus ln r is equal to kt. Now we know that a mathematical formula, that is ln m minus ln n is equal to ln of m by n. Then ln r naught by r will be equal to k into t. We can also convert this ln into natural log by multiplying with 2.303 into log of r naught by r equals to kt. Now we know that the straight line equation is y is equal to mx plus c. In the straight line equation, y represent the y-axis and x represent the x-axis. Here m represent the slope and c represent the intercept. Now we can plot the graph of ln r versus t and ln r naught by r versus t by using the straight line equation y is equal to mx plus c. Okay, what we have learned today? We have learned about the first order kinetics. What is the first order reaction? First order reaction is a reaction in which rate is proportional to first power of concentration of the reactant molecules. And what is the integrated rate equation for the first order reaction? That is equal to ln r is equal to minus kt plus ln r naught. Now your today's homework is to plot the graph of ln r versus t and ln r naught by r versus t by using this straight line equation.